Hello everyone and welcome to this online version of my Nordalida presentation of this paper called Synonym Replacement based on a study of basic level nouns in Swedish text of different complexity. It's written by me, Evelina Rennes, and I'm a PhD student in computer science at Linköping University in Sweden. And co-authoring is Arne Jönsson, professor in computer science at Linköping University. And this is the outline of the presentation. I'm going to give you a short background of this study and our motivation for doing it. I'm going to account for the two corpus studies that we conducted. I'll present the algorithm that we ended up with, and finally present some preliminary results and propose future work. So, for those of you who are not familiar to lexical simplification, it's a subtask of automatic text simplification, and it aims to find and replace difficult words or phrases with simpler options, but with the same meaning. And it can serve several purposes, but the most immediate purpose of lexical simplification is to make text easier to read for different target audiences, such as people with dyslexia, aphasia, intellectual disabilities, people with hearing impairment, children, and so on. And this is one common way of describing the process of lexical simplification. You identify a complex sentence, you identify the complex word or phrase of that sentence, you generate substitutions, you select and you rank them, and finally produce a simple sentence with the selected lexical unit of substitution. And the work that we present today is focused on generation, selection, and ranking. And I'm just going to mention something about hyponyms and hyponyms. So hyponymy describes a semantic relation between a subordinate word, called a hyponym, and a superordinate word, called a hypernym. So, for example, the lexical relation between Shetland pony and horse would be that Shetland pony is a hyponym of horse, whereas horse is a hyponym, a superordinate word to Shetland pony. Then the second part of theory that we build this method on is basic level words. And the idea springs from prototype and categorization theories, mostly associated with Eleanor Roche and her colleagues in the 70s. And in short, prototype theory means that there are two governing principles that give rise to the human categorization system. We have the principle of cognitive economy and the principle of perceived world structure. And the principle of cognitive economy states that humans use an economic approach to information gaining so that they group similar stimuli into categories to gain the most amount of information as possible while minimizing cognitive effort. And the principle of perceived world structure states that humans form and organize information about the world based on correlation in its structure. So, for example, it's difficult to find necessary and sufficient traits of birds that create a neat bird category. But prototype theory claims that we rather have a correlational idea of a bird, saying that most have feathers, most can fly, and so on, which allows us to create an idea, a prototype of a bird. And then we can have a more prototypical idea of a bird, perhaps being a robin or a magpie, and we can have a more peripheral member of the category, perhaps being an emu or a penguin. And Roche identified a basic level of categories with several unique features, such as being the most inclusive, the most informative, and so on. So what does this mean to us then? Well, according to this idea, there are words that are more basic to us than others. And what does basic mean then? Well, among other things, it means that they emerge early in language acquisition, they are frequently occurring, and they are usually also monolexemic, which means that they consist of one single lexeme. So in this example taxonomy here, kitchen, chair, furniture, the chair would be the basic level word here. And our study then, well, it started off as a corpus analysis, where we wanted to see whether we could see any difference between corpora of simple Swedish and corpora of standard Swedish from this respect. So we conducted two analyses, and the first one was on SUK 3 and last part, two general corpora of standard Swedish and of simple Swedish. And in the second study, we restricted ourselves to the genre of news text, comparing a Swedish newspaper corpus, the GP2D, with a corpus of simple news, the 8 sidor, or 8 pages. And we wanted to investigate if we could capture this notion of basic level words in the simple corpora. So what we did was that we extracted all nouns of the corpora, and the expectations were that we'd have to climb higher up in the word taxonomy to reach some kind of top-level concept in the corpora of Standard Swedish than we'd have to do in the corpora of Simple Swedish. And this built on the assumption that the Standard Swedish corpora had used a higher ratio of specific words than the Simple corpora. So we recursively collected the primary descriptors of each noun from Saldo, and you can read more about this in the paper, but Saldo is a descriptive lexical research that among other things, includes a semantic lexicon in the form of a lexical semantic network. So we recursively collected the primary descriptors until reaching the top level, or until the primary parent was no longer a noun. So we ended up with word chains, or taxonomies, and the number of steps taken to reach the top level noun was then counted. So for each noun in the taxonomy, we also collected information about frequency and compositionality. And what we saw was that the words of SUC 3, so the standard corpus, had a slightly lower number of steps to the top level noun than the words of Laspard, which is noteworthy since we expected it to be the other way around. However, when looking at the news corpora, the standard corpus GP2D had a slightly higher number of steps to the top level noun than the simple news corpus, and this was expected. And this graph shows the relative frequencies of the words of the different corpora. So on the x-axis, we have the different levels, where level n corresponds to the actual words of the corpus, and each plus level is one level up in the taxonomy. And all corpora, except for the Laspard corpus, exhibited a tendency of peaking at level n+3. And this could be due to the fact that when climbing higher up in the hierarchy of superordinate words, more general words are found. So these words are often more frequently occurring than words with a more specific meaning. And when searching for synonyms, we hypothesize that the more general words are not necessarily good synonym candidates. For instance, whereas horse could be a good enough synonym candidate for Shetland pony, the word animal might be too general. Thus, we chose to restrict our synonym-seeking algorithm to not go beyond level n+2. And based on the theoretical background of cognitive linguistics, we learned that basic level words are more frequently occurring in language, and also often monolexemic. Thus, an algorithm for synonym replacement should reward synonym candidates that have high relative frequency and consist of one single lexeme. And based on the corpus analysis, we saw that there seems to be a frequency peak at level n+3, which could be an indication of a too general word. So we chose to restrict our synonym-seeking algorithm to not go beyond level n+2. And the combination of insights resulted in this algorithm. From the word chain or taxonomy, we extracted the 3 first words. We sorted them according to frequency. And the most frequent monolexemic word, if there was any, was regarded the best synonym. And we call this algorithm the FM algorithm, and it basically stands for frequency monolexemity. And so we assessed it by comparing it to other strategies. The one-level strategy is an algorithm that climbs one level up the taxonomy and chooses the next word as synonym. And the one we call FREC chooses the most frequent word as a synonym. And then we have, of course, our own FM algorithm, which chooses synonym based on a combination of frequency measures and monolexemity. And here are some examples of how the different strategies chose synonyms. And we can see that they varied a bit. In this first example, we have the chain percent, centesimal, fraction, and part. And we can see that the FM chose percent, whereas one level chose centesimal and the frequency-based strategy chose part. So basically what we see is that the FM algorithm didn't make any substitution here. And in the last example, we can see that as a synonym for the word ruble, the FM algorithm and the frequency-based algorithm both chose coin, whereas the one-level algorithm chose currency units. And we haven't evaluated the methods yet, but what we did was that we compared the resulting synonym choices according to how many monolexemic or polylexemic words they chose, and counted the relative frequencies of the chosen synonyms. And this graph is perhaps a bit counterintuitive, but what you can see here is the words of the SUC3 corpus and the ratio of monolexemic and polylexemic words it contains before and after applying the 3 different strategies. So if we look at the x-axis, the bars labeled words are simply how many nouns we had extracted from the corpus. And then we have the different algorithms in different colors. And the gray bar here represents the original values of the corpus. So we can see that the corpus contained around 136,000 monolexemic words and 70,000 polylexemic words to begin with. And what we can see then is that all simplification strategies resulted in a higher ratio of monolexemic words than the original corpus, with the FM algorithm scoring the highest number, which is in a way expected since we chose to reward this. And we see the same tendency in the standard newspaper corpus. If we then look in a similar manner to what happened with the relative frequencies after substituting the words, we can see that all strategies increase the relative frequency scores in the words of both corpora. Obviously, the largest difference can be seen as in the strategy that rewarded high-frequency words, but we can still see a slight increasing number in all strategies. So, to conclude, we presented techniques for finding the best synonym candidate in a given word taxonomy. And we saw that all synonym replacement techniques, including the baseline methods, increased the number of monolexemic words and relative frequencies. And the algorithm that we presented, the FM algorithm, aimed to reward high relative frequencies and monolexemity, while not climbing the word hierarchy too high. And it seemed to perform well with respect to these criteria at least. So basic level nouns could serve as a complement to the often used synonym replacement methods that rely on word length, for example, or word frequency. And future work then obviously includes the evaluation of these strategies, as well as a comparison to other synonym replacement strategies. Okay, thank you.